This new chapter is triangle stuff. So eventually, well, the stuff we're doing, you need to remember AAS, SAS, SSS, and all that stuff. This first chapter or section is perpendiculars and bisectors. We've already done these two constructions. We are going to have to do them again in problems that we do. Not today, but eventually. So, if you have a segment and you want to make a perpendicular bisector, all you do is from each end, you make a mark below it and above it. Keep it the same. Come over here, do it. Find out where they intersect. And then you just got to connect those 2 points, and it makes a perpendicular bisector.
Yeah.
Okay, now, on like when we do the test and when you do some assignments, you're going to have to just sketch angle bisectors, perpendicular bisectors, and what it's going to be altitudes and medians and stuff. So you don't need to use a compass on all of these, but when you sketch them, you do have to show that it's perpendicular, so everyone knows what to do then. How do you show it something's perpendicular?
Oh, the thing in the marks.
Put the little box to show that it's 90. And then bisect, everyone remember what bisect means? Cut in half. So to show that this is cut in half, you got to show that this equals that. So I'll remind you of that, but whenever you do any sketches, you got to put those little marks in there to show what it is. Now, the thing about a perpendicular bisector, the thing you need to know about it, is any point you pick on this line. Doesn't matter if it's way up here, right here, down below. Any point you pick on there is going to be equidistant, which is equal distance, from the two endpoints of the original the segment. And the reason why is this. When I draw this in here now, what are these two things? They're right triangles. And are they congruent to each other?
Yes.
And what's the reason why they're congruent? SAS. It's got a shared side here. SAS. So since they're congruent, that means all corresponding parts are congruent. This angle would equal that one, this angle would equal that one, and this side would equal that side. So what that means is that any point on the perpendicular bisector, whether it's here, 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 down below, will be equidistant, the same distance from each endpoint. Okay? So that's what you need to know about a perpendicular bisector. Then the angle bisector. Again, we did this construction. So the way you make an angle bisector is from the vertex, you just make any arc. Yeah? And then from those two marks, you keep it the same, and you get an intersection there, and then you just got to connect that. So, since that is an angle bisector, that means it cuts the angle in half. So that means this angle would equal this angle, right? Now, when we did the perpendicular bisector, any point on this line is equidistance from each point. Any point on this line is going to be equidistance from each side. So that's the difference between the two. The angled bisector gives you the points that are the same distance from the sides. And the way you draw that, like say I wanted this point, to measure you can't just measure any random line. You gotta measure at a 90 degree. Okay? So if you make 90 degrees there, that means this line will be the same length as this line. And again, we could prove that because here we have two triangles, right? They are right triangles. And this was just marks for my compass, but remember I measured straight out to get this mark and this mark, right?
Mm-hmm.
But we have two 90s here. We know these two are equal because it's bisected. What else do you know is true? Shared side. So what makes these two triangles congruent? Not hypotenuse, leg. The hypotenuses are, but we don't know a leg. Huh? AAS. Angle, angle, side, angle, angle, side. Which means all corresponding parts are equal. So that means that this piece does equal that piece. Okay? So those are the two things, perpendicular bisectors and angle bisectors. So the perpendicular bisector works both ways. If they tell you something's a perpendicular bisector, then you know any point on that line is the same distance from each endpoint. So that's what you have to realize, is that that length will equal this length. So the type of problem we'll have is, if they tell you this, they're very simple problems. If this is 10, they're going to ask you, what's the length of CB? 10. That's how easy it is. Now it works the other way too. They'll tell you this. If you got a picture like this, but they don't have the 90 and that these two are equal, if they tell you that D is equidistant from A and B, what that means then is that this is the perpendicular bisector. So if you know these two are the same distance, you know this is 90 and you know those two are equal also. So in this picture, they tell us that BE is the perpendicular bisector of AC. So since it's the perpendicular bisector, I know that this equals that, right? Because bisect means it cuts it in half. And what else do you know? What do you know about point B?
Equal to A.
Any point on the perpendicular bisector okay, what I just went over, if you've got a segment and you draw the perpendicular bisector, what do you know about any point that lies on that line? It's equidistant from the two endpoints. So, since this is a perpendicular bisector, what do you know about point B? Equidistance from C and A. So that means that AB equals CB. From this information, you need to know all of this. So in part A, they say what segments are equal? AE and EC. And AB and CB. Now, this one is another question that's so easy, it's sometimes hard. It is in your assignment. It is on the test when we take the test at the end of the chapter. AP equals CP. They tell us that this length equals this length. What can you conclude about point P then? It's just the converse of what we just did down here. If this point P is the same distance from these two endpoints, anyone know what could you say about point P? I'm not thinking anyone will get it, but just in case. It's just the converse of this. If a point is on the perpendicular bisector, it's equidistant from each endpoint, right?
Yeah.
So backwards is, if it's equidistant from each endpoint, it is on the perpendicular bisector. So what we can conclude about it is it's on the perpendicular bisector. You can kind of tell by looking at it, but the line doesn't go all the way up through it. So all that confirms is, if this point is the same distance from there to there, that just means if you extend this line up, it would go through P. So that tells us that P is on the perpendicular bisector. So if you had a picture like this, and they told you that XY was congruent to XZ, even though it's not drawn, that means if you connected them, they'd be the same. What can you conclude about this point? Since it's the same distance from each endpoint. It lies on the perpendicular bisector. Okay? So those are problems on your assignment. Angle bisector we already talked about. If you bisect an angle, any point on that line is going to be equidistant from the sides. So this length will equal that length. If this is 3, they'll ask you how long is BD. It's 3. It's that simple. And then that works both ways too. If you see this picture and they tell you that this equals that, what can you conclude about point D? Think of the last question. It what? It lies on the angle bisector. Okay, they're the same type of questions, it's just with perpendicular bisector and angle bisector. Okay? Now the two types of problems like these, which you'll see, I don't think it's this lesson, but one of them. Here's one example, is there's a lake and there's a house on either side of the lake, and they want to build a well or dig a well, and they want to share it so they save money. This person wants to dig it right here, but this person doesn't like that. You know why? They got to go further, right? So the way to figure out what's fair is if you connect these two, and then you make the perpendicular bisector. Anywhere on this line is going to be equidistance from each house. You could put it way out here, because then they're the same distance away as them. But obviously you'd want to make it, they can't walk over the lake, so it'd probably be there and there. Okay? So to find a point the same distance from two other points, you do the perpendicular bisector. The angle bisector, here's the type of problem you'll have to do is, if there's streets, so you got an intersection that's like this in a city, and they want to put some sort of monument in the park here, and they want it to be equally visible from each road, which means same distance from each road, you would construct the angle bisector. So you could put that monument anywhere on that, and it would be the same distance from each road. Okay? So here, another simple problem, but maybe it's too easy. So easy it's hard. They have a baseball diamond. What can you conclude about the measure of angle SHF? SHF is this angle. What can you conclude about it just by looking at that picture? The measure of it.
It's the same as SHT.
It is the same as SHT. So what can you conclude about the measure?
SH is equal
not that hard, come on, someone say it. What's the measure of it? 45. 45 degrees. If this is 90, they'd be cut into two 45s, right? So, it's so easy, it's hard, right? So, and here, this is an example. They tell us that PQ, right there, is congruent to RQ. So, whenever you see that, you need to realize, since Q is the same distance from each endpoint, this is a perpendicular bisector, which means this is 90 and these two are equal, right? Make sense? So, then they say, can you conclude that S is also on the perpendicular bisector? The only way S is if this length equals this length. So from these markings here, I've got two big triangles here, two right triangles. Are they congruent?
Yes.
And what's the reason? SAS, side angle, it's a shared side. Side angle, shared side. So since they're congruent, PS has to equal RS, which means S then is on the perpendicular bisector because it's the same distance from P and R. Okay, here's another one of these that are so easy it might be hard, I don't know. In the diagram, D is on the bisector of ABC. So here's angle ABC. D is on the bisector, which means if you drew the bisector, it cuts it in half. So they're asking, what is DC? 6. All right, it wasn't that hard. Since it's on the bisector, that means it's the same distance from each side. Since that's 6, that's 6. Looks like an 8. Okay, we're going to do a few of them together. Yeah. For number 3, 4, and 5, the directions say that CD, right there, is the perpendicular bisector of AB, which means this equals that because it's a bisector, and since C is on it, that means these two lengths are equal also. So, for number 3, what's the relationship between AD and BD? They're the same, so you can just put they're congruent. Or equal, whichever one you want to put. You can just put the sign. What's the relationship between angle ADC, which is this angle, and BDC, this angle?
They are.
It's real easy.
They're both right.
They're what?
Both right track.
So they're both 90, right?
Yes.
Yeah.
What's the relationship between AC and BC? How are they related? AC and BC. They're the same, they're congruent also. Then 6 and 7 is the angle bisectors. It tells us that ray PM is the bisector of angle LPN, which means this angle equals that, and it means this side would equal that because they're equidistance away. So, what's the relationship between angle LPM, this angle, and NPM, this angle? What's their relationship? They're what? Congruent? Or the same, you could put. How is the distance between point M and ray PL related to the distance between point M and ray PN? They're congruent. They're the same distance away. So 8, 9, and 10, you got to tell whether the information allows you to conclude that C is on the perpendicular bisector. And on 11, 12, and 13, you got to say, can you conclude that P is on the angle bisector? So, none of these are yes, just so you know. No. So, why? I already told you the answer that this is no. C is not on the perpendicular bisector, but you got to put the reason why. Why do we know that C?
and B and C are equal.
Right, this is 8 and that's 7. They got to be equidistant. So the easiest thing to say is AC is not equal to BC. If you wrote it out, you would say C is not equidistant from A and B, but it's quicker to write that.
Yeah, clever.
Number 9, why do you know that C is not on the perpendicular bisector? It's not. It's not perpendicular. Perpendicular bisector means it has to be 90 and it has to be equidistant away. So 10, you know what you would put? It is perpendicular.
AC is not the same as C.
BP and BP are. They're not.
Right,
congruent.
it's not bisected. It's gotta be a perpendicular bisector. So remember when you get down to here, they have to both go 90 degrees to the side, and they have to be the same distance away. So here, the thing that's wrong is they're not the same distance away.